morning, guys. Okay, so today we're going to look at, and you got to forgive me on this, by the way, because your class, I kind of snuck ahead into scale factor a little bit with you guys. I know we were looking at that Desmos activity. So I'm going to kind of record this as starting from scratch. You are going to hear some repeats. So I apologize, but let me show you. First of all, when I was going over scale factor today, my kids, when we first started talking about it, they asked a question. They were like, well, haven't we been doing scale factor with our similar figures questions? And so that's where I want to start, because yeah, we kind of have been doing scale factor problems with similar figures, but there's a slight difference on the type of answer you're giving me. So for similar figures, this is a perfect example of a question I could have given you and asked, are they similar, right? We have lots of different ways that we could do that. Or I could even take a number out, and using your knowledge of similar figures, you should be able to fill in that hole for me. So how scale factor is different is not just the fact that you know two shapes are similar, but how are they different? And I know that sounds interesting because the similar figure, but what I mean by that is, in this case, if I started here, if this was, I consider figure A and figure B, if I moved from one to the other, what is the scale factor that it shrunk by, right? What is that kind of magic number that all of these numbers reduced by with multiplication, okay? That's what I'm going to show you how to find today, okay? We'll actually come back to this problem in a second. So again, sorry for the repeats, but it's probably good for your brain anyways. Because remember on Friday, we had like the crazy prank with Russian voice over, what's that called? What's that called? Where they have the voiceover? Is that a voiceover in a movie? I'll have to Google that afterwards. I'm not going to waste your time, but so this scale factor there are two types, remember, an enlargement or a reduction. And remember, you guys know this, the fancy math word for scaling something is to dilate or make a dilation, okay? That really is the more kind of grown up word that you'll start using next year for sure. I'm gonna try and just swap them out interchangeably so you don't have to worry about it, okay? Remember, at enlargement, these are numbers where that scale factor, which is also referred to as K sometimes, don't shoot the messenger, is greater than 1, right? It has to get bigger. Whether it's 2 times as big, 1,000 times larger, or even 1.001, where it's technically a small enlargement. Sounds funny, doesn't it? Reduction is the where K is less than 1. But I also want to point out that it needs to be greater than 0. When you multiply something, because remember, scale factor is all multiplication. If you were to try to scale something down and you want to scale it down using a scale factor of 0, it no longer exists, right? 0 is the absence of value. So it really does make that image disappear. You also can't have a negative scale factor, right? 0 is kind of the stopping point. Your image is gone if you have a scale factor of 0. So, I always think it's important to remind kids, like when I say less than 1, I really mean in between 0 and 1, okay? Remember, if the scale factor is 1, there's no change. It just stays itself, okay? Now, when it comes to finding scale factor, there's really one ratio that I want you to really memorize. I hate to say memorize, and I just realized there's no real space to put it, so that's okay. I'm going to put it down here. To find the scale, in fact, I'm going to put it right here. This is great. To find the scale factor, it's the new length over the original length. So we really just need 2 measurements from those shapes in order to determine the scale. So I have some options. I could use 10 and 4 for that ratio, right? They're corresponding. Or if somebody else wanted to use 5 and 2 to make the same comparison, we should get the same answer. We only need one of those, okay? So again, we want to take one measurement from our new shape and put it over one measurement from our original shape. So immediately we need to kind of identify what's the new one, and the model sometimes it's referred to as, or the scaled drawing, the dilation, right? Just keep an eye out for that. So our original drawing is the small car. So I'm going to pick yellow because I want to be positive today. So I'm going to use 2 in my ratio underneath where the original length goes. In fact, my advanced class, when they saw new over original, they saw the word no. Think no, N-O, new over original, no, okay? So I've got my O, my original, and then I need to grab its corresponding side on the new version or scaled copy, and I'll plug that number in as well. 5 over 2. Now 5 halves reduces to 2.5. Okay. Now, just to prove to you, I kind of want to do the other one too, just to show you if I had used the other 2 values, I'd be putting the new over the original, and 10 divided by 4 is the same as 5 divided by 2. In fact, it's just the simplified version of that fraction. So, okay, so that's really all we have to, and 2, kind of recheck yourself. This car got bigger, so I'm expecting a number that's bigger than 1. And that's what I got. I got 2.5. So that makes sense. Okay. Okay, another one, or more 2 examples. I'm going to have you guys do this one. Okay. So I'm going to put the new over original. So this we're going to be really careful because it really is just a plug-in game, but it's kind of like you're asking to plug the number in the wrong place if you don't really pay attention. So the original is my 5. It happens to be on the bottom of these 2 also, so that's kind of nice. The model is my new, and then 30 divided by 5 is 6. I have a scale factor of 6. That means it got a lot bigger. And I can kind of see that. It went from 5 to 30. It did get quite a bit bigger, right? So I'm going to have you guys do this one. Make sure you're plugging in the values again in the correct location. I'm also going to have you guys do a little bit more. We're not going to worry about this lower example just yet. I want to focus on these up here. So this is just really interesting to me to estimate scale factor. For each pair down here, we're going to decide if the scale factor is greater than 1, equal to 1, or less than 1. You do not have enough information without getting a ruler out to measure these to find the actual scale factor. But you can tell me if it's greater than, less than, or equal to 1. So from P, and I'm only going to do this first one for you. I want you guys to do the rest. From P to Q. So I'm going to just draw an arrow for myself from P to Q. It got bigger. Therefore, I know that the scale is going to be greater than 1. Okay. I want you to do that for B through G. From each shape, one to the other, would you expect to have a scale larger, less, or equal to 1? Okay. And then we might do that last one more example together. Okay. All right. Let me screen share. There we go. I will see you soon for our meeting.